Okay, now that we have looked at balancing chemical reactions and the different types of chemical reactions, we're going to look at what if we are given just our reactants? Can we predict what the products are and tell what type of chemical reaction is? And the answer is yes. So before we do that, we have to kind of look at what are the characteristics of our reactants in our different types of chemical reaction, because that guides us to what our products are. So the first step here is to identify what the type of reaction is based on the number and type of reactants. So a couple of them are really easy. If your reactants are carbon, hydrogen, and oxygen, that means you have combustion. Combustion only ever has carbon, hydrogen, and oxygen in our reactants. Now, I'm not telling you what the actual formulas are because that can vary, but if the only 3 elements you have involved are carbon, hydrogen, and oxygen, you have combustion. And the nice thing with combustion is the products are always going to be CO2 and water. So if you determine that you have a combustion reaction and you need to know what your products are, carbon dioxide, CO2, and water, H2O. Those are your products. You can go ahead and balance. Now, if you only have one reactant, you have decomposition because there's nothing for it to react with. It just is breaking apart into its elements. So if you're given one reactant, you are going to break that reactant down into its elements. Okay, and your reaction is decomposition. Now, sometimes in a decomposition reaction, you will have one compound break down into one element and another compound. We're just always going to assume that they break down into their individual elements. So go ahead and break that down. Most important thing to remember there is that you don't miss the diatomics. So the bromine, hydrogen, oxygen, nitrogen, fluorine, iodine, chlorine, because those come in pairs. So if you have one of those, make sure you put the subscript 2 on it. Now, if you have 2 reactants, that's when it gets a little more tricky because all 3, synthesis, single replacement, and double replacement, all have 2 reactants. So I separated those out into a whole nother category here. So are your 2 reactants 2 single elements? If they are 2 single elements, you're going to put them together, crisscross the charges, your reaction is synthesis. You should end up with one product. If you have an element and a compound, you're going to first determine whether the element in the compound and the single element will actually replace each other, or which element the single element is going to replace. So if the single element is a metal, it's going to replace the metal. If the single element is a nonmetal, it's going to replace the nonmetal. So determine which of those it's going to replace. Don't forget to crisscross your charges and check for diatomics. Your reaction is a single replacement. Now, if you have 2 compounds in your reactants, then you need to switch the anions, so those are the negative ions, with each other. You don't want to forget to crisscross your charges. Now, realistically, you're trading partners. If you don't want to trade the anions, go ahead and trade the cations. Just don't try to mix them up. You keep your anion together. So if your anion is a polyatomic, it needs to stay a polyatomic. It's not going to break apart. That means you have a double replacement reaction when you have 2 compounds. You're going to do that. Switch partners, you're done. Okay, so now a little reminder about diatomics. What are they? They're special elements that come in pairs when they are by themselves. These are not bonded to another element. Okay? If they're bonded to another element, they don't necessarily need the subscript on them. So think of it like shoes and socks. When you go to the store, you can't just buy one shoe or sock. You have to buy a pair. If we're going to have bromine in our chemical reaction, we have to have a pair of bromine stuck together. So bromine, hydrogen, oxygen, nitrogen, fluorine, iodine, chlorine. I like to call these the Brohn-Fickles. Some teachers call them the sneaky 7. Some teachers just refer to them as diatomic. So your teacher might have a different way of going about that, but just know those are all common names and you need to account for them going forward. Okay, so let's do some practice. What are the products of the following? Okay, take a second, pause the video, look at these, see if you can predict the products on your own. Okay, hopefully you took some time to do these on your own. Now let's look at these. Now for this first one, I have Na and O2. Okay, now Na is sodium, it's a single element. O2, that's a diatomic. So even though I have this 2 subscript, it is not a compound. It's again a single element, just oxygen. Okay, so this one is going to be synthesis, and I'm going to put them together. I'm going to have one product. Now this one is, sorry, those all came up at once. You can check your work if you don't want to listen to me, but this one, AgNO3, this is a compound, and CaO is another compound. So I'm going to switch. My NO3 is my anion, the O is my anion, so I'm going to switch those, which means my Ca is going to become bonded to my NO3, my Ag is going to become bonded to my O. Now I got these subscripts here by figuring out the charge on calcium, figuring out the charge on nitrate, and crisscrossing them. And again, figuring out the charge on silver, figuring out the charge on oxygen, and crisscrossing them. Next one is an easy one. Carbon, hydrogen, oxygen. Now they're in a different ratio that might not be the same in everyone, but I can quickly identify this as combustion. CO2 and water are my products. Next one, copper, single element, and NaCl, sodium chloride. This is a compound. So when I have a single element and a compound, I got to figure out which part of this compound is this copper going to try to replace. Okay, so copper here is a metal. It's going to replace the metal in my compound, which is the sodium. So copper replaces the sodium, kicks it out to be by itself, and I get copper chloride and sodium. Now, H2O, only one reactant, which means it's going to break down into its hydrogen and its oxygen. It's two separate elements. Now, notice I have the 2 and the 2 because H2O2, those are both diatomic, so I need to account for that in there. Now, none of these are balanced, okay? I did not go ahead and do that. If you are still struggling with balance, this would be a really good opportunity. You have 5 problems in front of you that you could go ahead and practice balancing with. Now, I already kind of alluded to this, but this first one was synthesis. I took 2 elements, put them together to make one compound. Second one was double replacement. I switched partners. Third one was combustion because all I had was carbon, hydrogen, and oxygen. Fourth one was single replacement. I started with a single element and a compound, made a single element and a compound. And the last one was decomposition, where we had one compound breaking down into single elements.